The technology I'm talking about today is the Aresian lens. It's a novel imaging element that enables compact, high-powered microscopy. This microscope is almost as good as a lab-grade microscope, but weighs 150 grams and costs under $75. Our first target market is online higher ed life science. As higher ed tuition continues to increase, quality online education is crucial for ensuring wide access to higher ed. Many science courses and even degrees can't be offered in online form because their labs require expensive equipment. This limitation is biggest for life science programs, which support health careers as well as pure science. Existing low-cost microscopes are not good enough for microbiology labs, but ours is. It offers better than 1 micron resolution at a fraction of the cost and weight of a lab-grade microscope. Online higher education also offers a very appealing market. It has a steady supply of students who each purchase materials every semester. And we plan to make our whole package more like an e-textbook than just a gadget. The e-textbook model is keeping college textbooks spent at over $12 billion a year, even as many publishing industries have crashed. These are shots of human blood taken through an Aresian lens microscope, operating at approximately 800 times magnification. Here's a detail of that previous image next to a lab-grade microscope operating at similar mag. So you see that the Aresian lens microscope is not quite as good, but it is really close, and again, with a 90% savings in cost and weight. Here are some conservative market size estimates based on enrollments, average student spend, and conferred degrees. We calculate a TAM of approximately $250 million a year in the US alone. This is not considering the broader e-learning space or global markets. There's competition in this space, so virtual lab software exists for basic bio and could be developed for advanced bio. Research generally shows that virtual labs are inferior, but they are cheap and easy. Other low-cost portable microscopes exist, but the best-in-class solutions have resolution around half hours. And universities could just maintain the status quo and bring students in online courses to campus for lab intensives. This is our current team. Chase is a software engineer and project manager who specializes in image processing, and I'm a researcher and technologist with expertise on educational technology. Thank you.
Okay, I'm going to ask the really stupid question. So who buys this?
Students buy this through college bookstores.
So it would come along, maybe be packaged with their...
With curriculum, with
their
textbook.
Textbook,
yep.
Or their...
Yeah, we're thinking about something very much like an e-textbook model for retail, yeah.
And then it's actually a small microscope?
It's actually a small microscope.
So they have it at home?
Yes.
Okay.
So I guess my question relates to the headwinds you might face. I guess I'm wondering, is the lack of this type of instrument really the barrier to providing widespread online science education like this? Is there going to be an inherent bias to bringing students in to work in labs that you're going to have to overcome, and that could be challenging to overcome? Just comment on that.
So the lack of this kind of instrument is at least one major barrier to offering advanced biology courses and, along with them, purely online health science and biology degrees. There is a bias, I think, in some quarters at least, against distance lab education. And I mean, there's a bias in some quarters against distance education generally. But the value prop of distance education is high enough, and the customer discovery we've done suggests that there is a potential large market of people who would really, really like to offer distance advanced bio. So, does that address your question?
Yeah.
Yeah.
And so you're developing a piece of hardware, but you're an instrument, but you're also developing software and curriculum.
That's right.
Those seem like very different skill sets, and I know that you have a team that has kind of a foot in both. Have you thought about how difficult it might be to combine those two things? Are you augmenting your team a little bit?
We are planning on augmenting our team. We would really, eventually we might like a CEO who's an optical engineer. And we are also seeking and currently developing strong partnerships with online higher education institutions or higher education institutions with strong online programs, hoping to get a lot of curricular development expertise from them. And even in-team curricular development expertise is never going to be a substitute for what instructors in particular courses need for curriculum. So we're going to have to partner with those people in any case.
One question, if I may. You did show some pictures,
Yeah.
your microscope versus the other, versus competition. If you can talk a little bit in terms of the delta, in terms of pricing, and then just one other follow-up question also that if you can blend that in.
Yeah.
You showed competition in US market. Just curious because there may be a significant market internationally as
Yes.
well, where it's about affordability maybe in rural areas, et cetera. So how is the company trying to position themselves? Is it the US market or international markets where the need may be? I mean, it's about how many people do you think out of 10 in your survey are going to buy it when offered that option in the US? And when you kind of look into where you're going to focus your energy here versus international?
So U.S. higher ed is definitely our first target market,
Right.
although we are certainly thinking about global higher ed markets and other markets even outside of higher ed downstream. There are additional accreditation, regulatory, local need hurdles involved, I mean, even linguistic hurdles involved in developing curriculum for global markets. Talking about the delta in terms of competition. So the other shot I showed you was from a conventional lab grade compound microscope, which I don't know the exact model that was used, but it probably cost about $800 and weighed 8 to 10 kilograms, which is, I mean, the delta there would be at least 6.5 kilograms and about $700.
Okay, so the cost is going to be about $100 for your product?
Ish, depending on where we position it alongside other textbooks and course materials.
Do you have a sense of how much it'll take to produce?
8 to 10 a unit.
$8 to $10?
Yeah.
Okay. 7, 6.
Okay,
Good.
with that, we're out of time.
All right. Thank you.
Thank you.